Okay, so thanks for inviting me. I'm going to talk about a little project that we did at Stack Exchange. Also a little plug for my blog. If you're not familiar with Stack Exchange, we're a network of 125 and growing Q&A, question and answer communities. Serverfault.com is our community for system administrators. I hope that you're all involved in it. And we love Puppet at Stack Exchange. We use it for managing all of our the Linux part of our infrastructure. So what are secrets? In terms of this talk, secrets are any kind of binary data that you don't want other people to know about, but you have to use in running your systems. So things like SSL certificates, at least the private key bits, any kind of passwords, API keys, and really anything that should have privileged access. So Puppet is really good at managing, really good at deploying secrets. You just use, for example, you use the file doohickey. John earlier called it resource. No, it's the doohickey. Use the file doohickey and you say, we have this SSL key and we want to deploy it over there, and Puppet takes care of that for you. Awesome. If you need to embed passwords in the middle of a configuration file, Puppet's great at that also. You set up a template like this ERB template, and you say, this is where I want that password inserted, and then you generate a little Puppet code. You set some variables with the passwords, and you say, activate this template using that data to fill in the template, and Puppet takes care of deploying it for you. Awesome. The problem, however, is that if you store your secrets in Git, you're going to have a bad time. People all morning have been recommending that you keep all of your Puppet source code in Git, and I highly recommend Git, Mercurial, whatever you're going to use. The problem, though, is if you start putting secrets in your Git repository, there's a bunch of problems you can get into. So typically, you do your development on your laptop, which means checking out your Git repo. It means copying all that data onto your laptop. Laptops get stolen. Who here has ever had their laptop stolen? I did. Freaked me out. Yeah, it happens. But also, workstations have guest accounts, and you think that that guest can't access files, and one day you check, and oh wow, permissions just happen to be set so they can see all my source code, which includes these secrets, right? Not a good thing. A technical way of explaining this is it increases your circle of trust. So there might be specific people that are allowed access to these secrets. Maybe just your webmaster has access to your SSL service. By putting these secrets in Git, you've increased that circle of trust. So for example, anyone with admin access to your company's laptops and workstations now is in that circle of trust. That might include your whole desktop support team, who maybe you've never met some of them, right? That's a different group of people in many companies. It includes your anyone with privileged access on your Git server. So the person who does your storage and your backup team, these people now have access to these secrets. It also, anyone that you want to collaborate with, in DevOps environments, developers are often working with system administrators, and you share a lot of code, and you want to be able to share your Puppet code with developers. It's part of the collaboration process. And now anyone you're doing that kind of collaboration with is in your circle of trust. And so when we total this all up, this can be dozens of people when typically maybe 5 or fewer people have access to these kind of secrets. So you have 3 bad options as far as this collaboration is concerned. One, you can deny Git access to these developers that you want to collaborate with, which hurts your ability to collaborate with them, so that's not good. You can permit Git access to these developers, which hurts security, as I said before. Or you can just email the individual files that they need to see, which it's just a big bowl of pain. So you don't want to do that. So we were in this situation at Stack Exchange, and we needed to come up with a different option. And our option was we were going to encrypt any file that contains secrets before it goes into our Git repository. So we're going to encrypt it with PGP, the GNU Privacy Guard. And if any time you need to edit a file with secrets in it, you would decrypt the file, edit it, and then re-encrypt it. So the Git repository only sees the encrypted files, which are encrypted securely enough that we can trust them to be copied all over the place. My laptop gets stolen, and unless the person stealing it works for the NSA, I pretty much trust that they're not going to be able to get my secrets. So, but what about the Puppet Master? How does the Puppet Master access these secrets? Well, what we had been doing was those secrets were unencrypted on the disk of our Puppet Master, and we decided that that's okay. Our Puppet Master is very much locked down. So anytime our continuous integration system pushes a code change, a new set of Puppet files to the Puppet Master, it would then run a script that would decrypt all of the files. So the files are decrypted at rest on the Puppet server. And this doesn't decrease security because if you get root access, well, only root and the user Puppet can access these files on that machine. If you have root access on our Puppet server, you've basically won the game anyway, so having access to secrets is not a reduction in security for us. Now, encryption's easy, right? I mean, these commands, you could just, type those over and over again, never make a single typo. Right, so cryptography is not easy, and cryptographers make it more difficult by making us type crazy commands like these. So imagine if any time, maybe about once a week, I actually need to edit one of these files. But imagine if every time I needed to, I had to decrypt the file with a command like that and re-encrypt it with a command like this, and not get any typos, and don't accidentally check in the unencrypted version as, because I'm rushing, and that would never happen. I find that security is 1% technology and 99% following procedures correctly. And any procedure with more than one step is probably not going to be consistently followed by everyone on the team. In fact, procedures with one step might not be followed consistently. And this is a known problem in cryptography. I mean, Hamilton has this just seminal paper from '99 about usability studies of PGP. So therefore, we automated this. We wrote some scripts that made this easier for everyone on the team, and we called the project BlackBox. So we've simplified those commands down to these basic scripts. Anytime you need to edit one of the encrypted files, you just say BlackBox edit start. That decrypts the file, prepares it for editing, and when you're done, BlackBox edit end, and the file name, and that re-encrypts it. It also shreds the unencrypted version. So it erases, shred is like RM, erasing the file, except it then rewrites the disk blocks with zeros to make sure that the next person that buys that blank disk on that used hard drive on eBay can't see it. There's some other scripts that are included. For example, enrolling a file into the system. The first time you want to encrypt it, there's some house cleaning that you have to do. You have to add it to the list of files that are maintained encrypted and do some other things. And so we automated that. You just run register a new file in the file name. There's also some processes that involve either encrypting or decrypting all the files. So, for example, when the Puppet Master gets a new load of Puppet files from our continuous build system, it needs to decrypt all the files, and so we have this post-deploy script that does that. We use Team City, which is like Jenkins and these other systems, and so in your environment, Jenkins would just call this script after pushing new files. We also sometimes need to re-encrypt all the files. So, for example, if someone left the team or if their key changed, we would need to decrypt all the files and re-encrypt them with the new keys or the new set of keys. Which brings me to an important point. Everyone has their own PGP key or GPG key in the system. So, little technical detail, the GPG encryption system has a couple different ways it can encrypt files. One way is called symmetric, which basically there's a password or passphrase that is used to decrypt the file, and you tell everyone in the group that same passphrase, and now everyone can decrypt it. It's kind of like having a root password that everyone knows, which is not how we wanted to manage this. We wanted to, we didn't want to manage this for a number of reasons, and, well, I'll go into that in a minute. So instead, GPG has a mode where you have to list the keys of all the people that in the future should be able to decrypt a file, and we use that mode. So we maintain a key ring, this is more GPG terminology. We maintain this key ring of all the keys of the sysadmins and anyone that needs access. And the scripts take care of all that. So the procedure for new employees when they join our system and team, they have to enroll themselves into this process. We tried to make that as simple as possible. It's a two-step process. First, they enroll, and then someone that currently has access approves their admission into the system. So a new user would create their GPG key, add their name to this BlackBox-admins files, and commit that into Git. And then they have to find someone else on the team that already has access, and that person runs these commands, which essentially are adding this person's key into the main key chain, re-encrypting all the files so that this new key has access, and then committing that change to Git. There's a third step, which I don't have a slide about, which is to test. So you then go back to that person and you make sure that they can decrypt and edit a file. We find that, well, like anything in software development, if you don't test it when you're done, you don't know if it really works. Okay? So I was going to do a live demo, but I'm always concerned about doing live demos with Wi-Fi, so instead I have a number of screenshots that walk us through it. Question?
Where is the keyring file kept?
The keyring, good question. Where's the keyring file kept? The keyring file is kept in the Git repo. Right. Oh wait, I'm sorry. Wait, where's the keyring file kept? You have to. That's a manual process. It's kept outside of the repo. Yeah. Would it be an issue if it was in the Git repo? Yeah. Oh no, I'm sorry. The public parts of the keyring are kept in the repo, but the private parts are not. In fact, there's actually a check in there that makes sure that the private ring.key file is a zero-length file, because if it's not, that means you screwed up your procedure, and it prevents you from accidentally checking that into it. Okay, so what does it look like to edit? By the way, one of the usability improvements I plan on making in the coming months is shorter command line names. To start the process, like I mentioned before, there's a edit start command. You run that, it asks for your passphrase, and when you enter that, the file is now decrypted. If you do an ls, you see the encrypted version and the unencrypted version. So you can now go in and edit that file. Let's say, oh, I don't know, let's say this is a couple months ago when a certain security bug required us to change every SSL, SSL key for all of our websites. Anyone else spend like the next 3 days making sure that every single one was changed? Yeah. not our actual bits. I can put that on the slide. Though, I could have just changed any one bit and it wouldn't have been. Okay, so then when you're done editing the file, you run edit end. It re-encrypts the file, shreds the original, and it even tells you what git command to run next. It doesn't actually commit it into git for you because you might want to make other changes. So that's sufficient for big files like SSL certificates and stuff. But what about little bits of text, like passwords and API keys? You wouldn't want to have to create a separate file for every little password that you want to store. So we use Hiera. For those of you that are new to Puppet, Hiera is essentially a database that Puppet can access. And so you edit your Hiera configuration. In this case, we added the BlackBox file. And then in Hiera, we have this blackbox.yaml file, which lists our seq loops. There we go. So now our passwords are in this file, this YAML file. We encrypt that YAML file when we're checking it in, before we check it into Git. In Puppet, this is the same code as before, where we set those variables with the passwords, but now instead, we do this database lookup. We say, hey, Hiera, what is the HA proxy colon read-only password? There's an optional argument to this function, which we always use fail, which means if you don't find it in the database, use the string fail. This way, when you're developing code on your laptop, for example, you don't have to decrypt all these files. You'll just get all these, your templates will be filled in with the word fail all over the place. And often for debugging, that's good enough. So the code is open source as of this morning. It's available on GitHub, and it's an MIT license. It's written entirely in Bash, and it's some of the cleanest Bash you'll ever have seen. It reads like English. And I have a backup slide about that if someone wants me to prove it. So what are the results of the project? In the first 9 months, the project's only 9 months old internally at Stack Exchange. In these first 9 months, we were able to completely eliminate all the secrets from our Git repo. 7 SREs and developers have used it successfully to securely collaborate. We have more than 50 files. We're a small little site. I don't know if 50 files sounds like a lot of files or a very few number of files. But we now have 50 full files that are encrypted and more than 40 individual passwords and API keys that it's used to store. And we use this for everything from SNMP, community strings to API keys. In the future, oh wait, we can cross that off. We're going to open source the scripts as of this morning. I have some usability enhancements planned. Someone just requested a command that essentially decrypts it and gives you a bash prompt, and when you exit the bash prompt, re-encrypts it, and it's done. So that will be done in a week. And better setup documentation. Since we just open sourced, I don't know how easy it is to install at sites other than Stack Exchange. So I'm looking for the first brave person to install it and give us feedback. And we're looking for people to join the open source project. Small little project, very unintimidating to get involved. And that's it. Q&A. Could be plenty of time for Q&A. URLs from this talk. Actually, since we have plenty of time, I'm going to do shameless plug. I have a new book coming out. It's the sequel to The Practice of System and Network Administration. Same 3 authors, me, Christine, and Strata. As an author, I guess I should say Strata, Christine, and I. And it's coming out in September, and people here today can get 35% off if you pre-order. So, and there's flyers all over the place. You haven't seen this. But let's take questions about BlackBox. I saw your hand up first.
Under normal use, can you just ignore all the encrypted stuff and just work with regular files in a small proportion of what they have in the repository?
Under normal use, can you ignore the encrypted files? Yeah, my normal mode of working is to leave all the files encrypted, and usually if I'm not working on a specific module that relies on that bit of information, Puppet is fine and just ignores the fact that that file is missing. For passwords, I usually get a fail, which is fine, usually debugging. And sometimes, if I'm just really lazy, I'll just create a dummy file. I'll just use touch to create an empty file in those places to squash any errors.
And Arturo, do you have a pre-commit check that does a sanity check for any file that exists in .jpg? There's no unencrypted variant, so you never check that in?
The question is, do we have a pre-commit check in Git that would prevent a commit if someone's accidentally checking in an encrypted file? Embarrassingly, no. I know that's really easy to implement, and I should, and the open source project is accepting patches. More hands, and way back.
Yeah, do all nodes have, all public clients have access to all the keys from there?
Okay, so the question is, do all the nodes have access to anything in Hire? Yes and no. So you can, if you want. You can also use Hire's hierarchicalness to make passwords only available to certain nodes. We have a very simple security domain, so we don't, we're kind of lazy and we just, all nodes can access everything. But yeah, if I was in a bigger environment with less trust of, the web servers don't trust the database servers or whatever, yeah, we do something like that. Yes?
I mean, is it possible to store all the keys in the S3 bucket, private S3 bucket, and let that get it from there instead of from here?
I'm not familiar with SD bucket.
S3.
Oh, S3. I guess you could. So the question is, can you just access the secret bits out of an S3 bucket? There's a higher backend for S3, so yes. Which brings me to, I was expecting someone to ask, why didn't we use YAML? Good question. Well, I have three excellent answers. First, it was much easier to transition to this. We didn't have to change any Puppet code if it was just the full file, because we just encrypted it, and then it was encrypted for us, but not for the master. The second reason is it's a lot faster. Everything's unencrypted on the master, which means the master doesn't have to decrypt things on each Puppet run. And the most important reason, it didn't exist when we started. And I don't have a time travel machine. But we've been very happy with it. And I think it's also, it might be easier for some people to deploy, especially small sites. But that's up for debate. Other questions? Yeah, one more.
Is this the type of thing that you can define which files need to be encrypted and sort of store that in the thing and then use this as a commit hook sort of thing? Or?
Oh, could we define a commit hook that would say, if the file ends in .kui, automatically ask for the person's password and encrypt it? You could make a Git hook for that. There's pros and cons. I guess it would be nice to have that kind of automation. I'd be concerned that since I don't know all the file extensions ahead of time, it might get people in the habit of thinking that it's just going to be automatic, and then when it doesn't happen someone has a .txt file that needs to be encrypted, and they forget that it's not automatic. Just a thought, but you could, sure. Okay.
Anything else?
Have you applied for the sources apart from? Have you applied for the sources? Have you created the kernel sources? Linux kernel source?
Oh, have we used it for sources? You could use it for any file.
Performance related thing, decrypting thousands of files.
I don't know if well, actually, our internal policy is not to put large binary files in the Git repo.
Source.
Yeah. But you could, my boss always does, and we have to.
But will it not impact the performance? If you have thousands and
It wouldn't, because well, it would impact the performance of pushing updates to the Puppet Master. You could probably optimize it a little by having it detect if the file didn't actually change, don't re-decrypt it, which I think is in there already. I just can't remember because I haven't looked at that bit of code in 8 months.
Excellent. Okay, big round of applause.